And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho, and today we'll be talking about the sun, climate change. Happy Valentine's Day to all of our viewers. And global cooling? First thing we'll do is talk about how the Smash News Network is the least busted name in news, while looking at some images of the sun in 193 angstroms. Major coronal holes in effect. One rising over here. More importantly, this one up here, we can expect a coronal hole wind stream from that in about 2 days. And we saw a pretty weak coronal hole wind stream from this one down here. We only made it into geomagnetic unrest for a period of 3 hours or less. And if you're wondering where the Solar Dynamics Observatory is, that is the location of it. It has a figure 8 style orbit just north of the equator, and we've had viewers regularly ask us how it is that the moon can obscure the SDO 2 times. And that is how it has two 180-degree bends in its figure 8 orbit. Here's another image of the sun, and we see a lot of filamentary activity here in the southwest, the northwest, and the northeast. So this is the southwest, if you're wondering. The west side of the sun is where space weather sets, and the east side of the sun is where space weather rises, hence the names east and west. And keeping an eye on that filament there. And when I say ion, well, the pun is intentional. Here's a colorized magnetogram, and we've got 0 sunspots, very weak solar activity. Basically solar minimum conditions. And none of those areas of magnetic organization are sunspots, at least not yet. We'll let you know by the end of the video the current state of affairs. Now, our viewers may be interested in where stuff is located, and since we're coming at you kind of late today, we're going to blast through data quite quickly. Here's where stuff is in the solar system. And here's where stuff will be in 1 week. If we're going too fast for you, please press pause. We'll be here when you get back. Next, looking at in-the-sky.org, there's a star chart. I draw in this yellow line known as the ecliptic, and I face mine to the south. I'm currently facing the south. So that 10.7 centimeter radio flux, which is a measurement of the outer solar coronal radio output, is at 71 solar flux units. There's the 1-year chart to put that in context. And there's the radio flux through the last solar cycle. It's proportional to sunspot number, and there you can see 0 sunspots and a weak radio flux. Essentially, solar minimum conditions. Let's look at volcanoes. I'm interested in what's been erupting. Are you? Well, here's the rundown. Sakurajima, volcanic ash not visible in satellite imagery. Please don't pole vault the caldera. Popocatépetl is emitting steam and gases. Please do not tightrope walk the caldera or play your mariachi band around the rim. Pacaya is exploding, flight level 100. It's a 10,000-foot ash plume above the Guatemalan volcano. Now back on the list, Pacaya. Fuego, also in Guatemala, exploding as well, flight level 150, 15,000-foot ash plume. Sangay exploding, 19,000-foot ash plume there. Please don't attempt a back handspring over that caldera. Revenador exploding, flight level 140. It's a 14,000-foot ash plume. Please do not attempt to jump your unicycle over that caldera. And Sabancaya, by the way, Revenador is in Ecuador, and Sabancaya down in Peru exploding as well, flight level 260. It's a 26,000-foot ash plume, which is more than we would prefer to see you attempt to hang glide over. Please don't hang glide over the Sabancaya caldera. Largest quake of the past 24 did not generate tsunamis. It was right off the coast of Fukushima, as you can see there, off the Isle of Honshu, Japan. And there's the location of that quake. Little uptick in earthquakes here over the past week. Let's run down the list. Or rather, run up the list. And you can sort this either way. I just leave it this way because I want the most recent earthquake at the top of the list. I don't totally change my life just to put out these daily space weather videos for you rubes and you non-rubes. Deep quake strikes near Fiji at a 4.5 magnitude at over 660 kilometers. Lots of aftershocks around that 7.1 magnitude quake at Japan. A deep quake strikes western South America as well as Tajikistan. Those are about 47 minutes apart. And just scrolling up the list, what do we have here? A very shallow quake at Thompson Springs, Utah. Let's check the location of that, as it's 2,100 meters above sea level, west of Grand Junction, as you can see, in the Grand Valley, at quite an altitude, something like 6,500 feet above sea level, folks. It's not a deep quake, it's a shallow quake. Another deep quake strikes near Fiji at 577 kilometers. In the deep quake capital of the world, Oceania. Also a deep quake at Bolivia. Small swarm of quakes there in western South America. There's that Bolivian 4.4 magnitude quake. And let's move on to talk about the smAsho stream. This is streamed live to Twitch. It's twitch.tv/smAshomash. Thanks to our followers over there. They've got a great mobile app. Perhaps check that out. Today's featured product is available from clicks at smAshomash.com. If you head to smAshomash.com, you can find our social media, our VoIP line, email address, etc. If you scroll down here and you click on the smAsho store, it's our first merch shop that we've ever opened. And the first merch that we ever put out is, well, the merch I'm currently wearing. So today's featured product is the Smasher Price My First Pandemic. There you go. The pathetic and infantile response of mankind trying to put a mask on the whole world in order to control a virus, which is a completely ineffective and ridiculous, pathetic solution to a virus. It didn't work in the 1300s, it didn't work in the 1900s, it didn't work in the early 2000s, it didn't work in the mid-2010s, and it doesn't work now to prevent viral transmission. If you'd like to pick up your own Smasher Priced My First Pandemic shirt, or perhaps a Mansa shirt, since making America not suck again is up to you. We made a shirt about it. But there's today's design, Smasher Price My First Pandemic. And it features the website on the front of the shirt. Gotta have it. Thanks to our subscribers over at YouTube, and the video can't continue until you press like and subscribe if you haven't already done so. And if you have already done so, press share. Head to your favorite social media outlet and tell your friends, foes, science noobs, and science pros, as well as your neutrals, that you watch the content and that you would prefer to see Smash News Networks not burned to the ground. You can pause the video. Again, we'll be here when you get back. All right, now that we've put out that fire, thanks to our BitChute subscribers also, and if you're only watching the content on BitChute, please watch us on YouTube as well. There's lots of exclusive content there that you're missing. Thanks to our patrons, a true source of funding for the content. Please consider becoming a patron at patreon.com/smAshomash. Thanks to our patrons. We make just about nothing on YouTube for making this content, so thanks to our patrons for increasing the probability that these videos will remain free and publicly accessible. Again, patreon.com/smAshomash. Please consider funding our operation. We are the world's leading solar forecaster. Who could have guessed we'd be here? But here we are. So let's do a cosmology segment. Did I fail to do the credit crawl? Let's do the credit crawl in reverse. It's the Patreon credit crawl. Our patrons get early alerts. Do you get early alerts? Well, if you're not a patron, probably not. You get late alerts. Let's do a cosmology segment. I'm going to pick a random number between 1 and 1031 because that's how many objects are tracked at the Neil Gorell's Swift Observatory, the Swift Burst Alert Telescope following X-rays. Today's quantum number is 124. Let's see what that object might be. And it is a quasar PKS 0347-211. A galaxy with its poloidal field oriented directly toward you. You can see its X-ray flux has been increasing in highs and lows over the past several years. Quasars have their poloidal jet pointed directly at you. So this particular object, let's just say that perspective is everything when it comes to viewing galaxies, and really indeed stars as well. as if you view a star looking directly at its pole, it looks totally different than if you view a star looking at its equator. So here's this quasar, and it looks like it's quite a distant one as it's very dim in optical light. And let's see if it shows up on the infrared spectrum on the 2MASS. And we see a heap and helping a nothing there. How about on the XMM, the multi-mirror project? Nothing there. And not showing up on the Chandra either. Let's see if we see anything on Finkbeiner. And by the way, we're going to talk about Finkbeiner at a later time. The helium alpha emissions, they're super important. And I guess let's just head back to the glimpse. Nope. Does it even show up on Simbad? Let's see. Anyway, there's that quite dim quasar. And perhaps we'll provide more details on that later. PKS 0347-211, a catchy name. And we found it at the Neil Gorell Swift Burst Alert Telescope. It's entry number 124. That's today's cosmology segment. Again, perspective is everything, folks. If you're looking at a galaxy and you're looking, so if this is the galactic disk, if you're looking at the galactic disk perfectly down the pole, like from this sort of perspective, you're going to see a very bright galaxy. If you're just off the pole, you'll see what we call an active galactic nucleus, a Seyfert 1 or Seyfert 2 type galaxy. And if you're directly in the poloidal field, it'll look brighter. It will not look like a spiral galaxy at all. It'll look like a very bright, almost like a star. And that's where quasars got their name. They're known as quasi-stellar objects. Back in the mid-90s, we didn't even know what it was. Now we realize that it's just the perspective. You're looking down the poloidal field of a galaxy, which is known as a quasar or blazar. Let's get back to data. The GOES X-ray flux has been flatlined over the past 3 days. We don't see any solar flares. And when we say solar flares, we're talking about the X-ray flux. We don't see any increases in the proton flux either. There have been no Earth-striking coronal mass ejections. And keep in mind that the GOES 16 makes its measurements around 300 kilometers of altitude. So to see protons on this, you've got to have protons making it into the ionosphere. Next, looking at the real-time solar wind, we've put up a 3-day chart here to show you yesterday's coronal hole. So this is the coronal hole wind stream that showed up. You can see the density increases first, and then the velocity increases as the density drops down, the standard signature of a coronal hole wind stream. I would also note that the BT-BZ shifted wildly as this coronal hole wind stream arrived. We saw the BZ make it all the way to -14. And I can't quite get it on the graph there. If you zoom in on that yourself, you'll be able to find that. And a BT of 14. So we had a very strong south polar field associated with that around that moment there in between when the density dropped off and the speed came up. Current conditions are solar wind density back to solar minimum levels, basically. 373 kilometers a second, solar wind, 373 kilometers a second for the solar wind velocity, solar wind density only 4 protons per cubic centimeter. And the BT-BZ has converged back on the 0 line. So we've got pretty equivalent fields coming out of both the North and the South Pole, and a fairly weak field at only a BT of 2. And here's the KP index, which is now at 2. It only made it to 4, which was kind of surprising. That coronal hole in the south polar region is quite huge. Next, looking at magnetohydrodynamic pressure. It's a geospace magnetosphere movie. It's 4 hours of data. We show it daily. It's a perfect opportunity to take a sip of your coffee, if you're me, while the data plays. And let's advance that to where it was before it annoyingly refreshed. And as you would expect, we see a fairly steady magnetohydrodynamic pressure here, as we see a fairly steady solar wind over the past 4 hours. Here's 4 hours of ground magnetic perturbations, and I would once again send your attention to this area right here, where we see significant changes in the Earth's B field, not only here, where the geomagnetic South Pole is actually located. So we've got two North Poles. One's over here somewhere. One's over here somewhere, making the net North Pole someplace like here. However, the South Pole, the South Geomagnetic Pole, is actually someplace like here. And yet we see lots of changes in the Earth's B field over here, south of South America. I find this interesting. I would also note two other spots that are important on the globe if you're a new viewer. The South Atlantic Anomaly, which is located there, has recently split, and now we have another anomaly down here. The two weakest spots in the Earth's magnetosphere, that's where approximately they're located. The South Atlantic and now the South African Anomaly. Are you unable to keep up? I know it's a lot of data. Well, we're going to blast through even more. Here's the GOES magnetometer over the past 3 days. And the Earth is solidly in the South Pole current sheet. No forecasts available there, really. Let's take a look at hydrogen alpha here real quick from the National Sunspot Observatory. Here we've got some data that's only 1 minute and 48 seconds old. And check it out. We can see some filaments actually right in here. And this is the El Teide, Spain ground-based system. And it's looking specifically at helium emission spectra at 6,562.8 angstroms, one of the emission spectral lines of ionized hydrogen. Next, looking at the current sheet. Here is the heliospheric current sheet, and you can see the Earth is solidly in this large South Pole-oriented current sheet shown in red, and will be there in the foreseeable future. Keep in mind the magnetic environment can suddenly change, and the data is about 1 hour and 34 minutes old. Here's a line of sight field plot. Shows you the B field in the solar magnetogram as well as the poloidal fields. And here are the sun's poloidal fields. And last, we'll look at the line of sight coronal hole plot, and quite a lot of coronal holes in the south. You can see that other one rotating in that we talked about earlier in the video. And we'll also show the solar coronal magnetic field plot. It shows you open potential field surface source lines in black or purple, depending on if they're at the poles or not at the poles, and closed ones in pink. It's a chaotic environment. I don't have no other comment. I have no other comment, folks. And now it's time for me to vanish, check the life of the stream, and get back to our diagram about the atmosphere. And thanks for leaving a comment. Thank you, Kathy Garden. Here's a diagram of the atmosphere, and we put this up daily because the F over there on the right. Are you F'd? Do you know about the F ionosphere layer? Well, it's located about 300 kilometers of altitude, and that is where the GOES 16 makes its measurements. Here's another diagram. It shows you the Van Allen belts because we're moving into the electron flux data next, which is super important to give us some of the most detailed insight into what's going on in the Sun-Earth system. The inner Van Allen belt shown there at about 1 to 8,000 miles, GPS satellites. And those electrons can charge up satellites. We do see some minor charging hazards here over the central Pacific Ocean and a bit of western Mexico. Here's the 3-day chart of the electron flux. And actually my forecast was dead on. Yesterday I forecasted it to be slightly lower than NOAA did, and I was right. NOAA was wrong. Cheers. Here's the relativistic electron flux chart for the past year. You can find this at solon.info/solar. Here's a visualization of it. And of course, that's not over a year. That's just a day. And we'll let that play through since it refreshed rather. And it's a little anomalous here. We're seeing significant electron flux at nighttime, and this is typically what we do see when we see very low levels of electron flux, and we're at quite low levels here. Moderate to low. And my forecast was exactly right. I forecasted it right there yesterday. Just one click below where NOAA forecasted it, which is the green box. The yellow diamond is the observation. And I think this is actually going to stay low. This is my forecast is for it to stay here or My forecast is for it to stay there tomorrow and then rise up 2 days from now. Next, looking at the ionosphere, here's a map of the frequency of vibration of the ionosphere. You're looking at megahertz. So millions of vibrations per second, megahertz. Ionosphere looking pretty normal here. There's the latest image coming in at 11 o'clock, as we're pretty late today. Let's talk about global cooling. Some hacks, some climate frauds have been talking about how the planet's warming because of carbon dioxide, and that the Arctic would be ice-free, and that Florida would be largely covered with water by the year 2000 or something like that. I started studying climate science in the late 1980s, 1987 or 1988, definitely that year, when I took 8th grade Earth Science, and I've been following it ever since. In any case, there is sea ice, and you see those red areas. Those red areas are 4.5 meters of ice or more. So while we're at kind of low levels here, we're more than 1 standard deviation above the 30-year average, which would be this light gray line here, medium gray line, I guess. The black line is the current situation. A little bit of ice building going on right now, but you can see it's within the range we saw last year and so on. Lots of ice around the east coast of Greenland, I might add. And the nonsense about Greenland being ice-free or melting is total nonsense. We've covered it repeatedly on the channel, showing that it's had 5 meters of snow from coast to coast all summer. Now let's talk about snow. Snow seems to be one of the mechanisms that causes Earth to turn into a snowball globe Earth. And if you look, practically everything south of the 40-degree line and everything north of the 40-degree line and literally everything north of the 30-degree line, except for the British Isles, are completely snow-covered. Also, I would note, does it look like Antarctica is melting, folks? Look at all the sea ice. It's summertime down there. So there's the snow cover. Here's the snow water equivalent, and look at how it's well above 1 standard deviation above normal. Here's the snow extent tracker, which has now moved back into the normal range. It's actually kind of right in the middle of the range there, having been all over the place this year. And last but not least, the snow mass balance. So this doesn't include mountains, but you can see we're well over 1 standard deviation above normal snow mass balance for the entire northern hemisphere. That's the 30-year average there, that blue shaded in area. Apparently the planet is so hot that it's cold. Now, one of the major canaries in the coal mine of how hot the planet is whether or not the Thames freezes in winter. And I've been saying since, 1987, that if we see the Thames freeze, that's pretty serious. Well, there it is. The Thames is frozen. Now that is located at Teddington. And I'm just going to leave that on the screen for a moment to let that sink in. The Thames has frozen. Is that because the North Atlantic Oscillation has shut down? I don't think so. I think it's because it's very cold in England. You can find this article at cityam.com. When Fulwell freezes over, Thames turns to ice for first time in 60 years. Will we have an Elfstedentocht in Netherlands? I don't know. Hopefully their canals will freeze and they can perform their Tour de France of speed skating. The 11-city tour, the Elfstedentocht, which has not happened for decades either. I'm hoping it happens because it's awesome. Let's move into meteorology, since we've now moved out of climatology and into the weather. Because, I know, right? Don't tell me. It's not cold. It's not cold because it's hot. It's hot because it's cold because it's hot. And don't confuse weather with climate and yada, yada, yada. Here are the jet streams of the eastern world. Here are the jet streams of the Western world. And if you had only one piece of weather data to look at, and you were traveling the whole planet, this would be the piece to look at. It gives you more insight in a quick snapshot of the planet's weather than probably any other thing. It's the 250 hectopascal winds at nullschool.net. Anyway, there are the jet streams of the Western world, and you can see it looks like they're having a warming spell there right now in Western Europe. And let's move on. Here are pressure cells, and the high pressure in the Northern Hemisphere is finally alleviating a little bit here. We're seeing a little bit more normal equalized pressures. Here's where we expect things to be at 12 noon Eastern time tomorrow, and if you're wondering where we're located, it's Lehigh Valley, Pennsylvania. Next, we're at lightningmaps.org, and we see some possible terrestrial lightning here. Maybe not. It's off the coast of Jacksonville. Hey, Daytona Beach, Jacksonville, Deltona, etc. Especially if you're in a tall building. Go have a look. It's a pretty active thunderstorm there. You may get some images of some sprites above those giant thunderheads that must be out there in the Atlantic Ocean. Take time-lapse photography, as some of the emissions that sprites put out are not visible to the naked eye. And let's see what's going on in the cloud layer. There's the cloud layer situation. Check it out, some rapid cloud nucleation right here. It's the NASA GOES shortwave radiation map. Here's the water vapor map, and check out the rotating low over southwestern Colorado. It's an atmospheric pond. It's an atmospheric pond. Please leave a comment if you're rich as hell living on a ranch in Colorado telling everybody else what to do. Again, there's the cloud layer. Check out the rotation of that. It looks like an inland hurricane, folks. Oh my God. And here's a U.S. Doppler radar map. So it's not generating a lot of precipitation there. Some snow in Utah, right at the Great Salt Lake. And ice storms continue. Still a band of ice storms here, mainly in Texas. Leave us a comment, let us know your situation. Heavy snow in the Midwest, it looks like, once again, as the jet stream is dipping way down. And there's going to be some ridiculously cold temperatures. Check out the power outages map. Lots of power outages. 275,000 out in Virginia. 118,000 in North Carolina. West Virginia, 13,000. Kentucky, 17,000. Texas, 24,000. And Oregon has declared a state of emergency. At least 211,000 customers out of 1.7 million tracked. And thanks Smash Team for tuning in. Please don't forget to press like and subscribe, press share, etc. Thanks for promoting us instead of fraud on the internet. There's our homepage. Again, don't forget to press share. And don't forget to check out our playlists, youtube.com/smashamash/playlists. And don't forget to tune into our bonus features. We've got a colorized magnetogram and a recently refreshed high-res solar intensitygram to show you a 0 sunspots. If there will be any, they would be at these areas of magnetic organization, of which there aren't many. Little organized region here, and here, and here. But no sunspots, folks. And let's close things out with a couple more SDO videos. We're going to show you We're going to show you 94 angstroms as well as a composite. So just bear with me a minute. Again, we are streaming live. Just one moment while that loads up. So here's 94 angstroms, folks. Check it out. We've caught a giant ionized iron sprite. Let's see if we can get that on screen for you. There it is. A giant sprite of ionized iron showing up there in 94 angstroms. Great view of that. And it's not a spaceship, because if it was a spaceship, it would show up in other spectra besides just ionized iron at 94 angstroms. Allow me to vanish. And here's a composite. This is 335, 193, and 94 angstroms all in one to give you that delightful purple color. And we are out. Thanks for tuning in. Remember, stare at the sun. Don't drink it. If you do drink, don't drive it. Since it'll never be now again, visit our links. Welcome to the Neo-Renaissance, and may that solar wind be at your back. We will be making another video later today, a live stream exclusive on YouTube. Don't forget to check that one out. Don't miss it. This has been a production of the Smash News Network.